Question number 1. A solid has a structure in which W atoms are located at the corners of the cube lattice. O atoms are at the center of edges and Na atom is at the center of the cube. The formula for the compound is A, NaWO2, B, NaWO3, C, Na2WO3, and D, NaWO4. All right. So let's consider this one over here. Let us say that this is going to represent the cube. So as we observe that in this particular cube, our first point that they have given is the W atoms are located at the corners of the cubical lattice. Now let's consider that these are the atoms W, which are located at the corners of the lattice, right? So it is located at the corner of the cubical lattice. So we'll take it over here. 1, 2, 3, 4, 5, 6, 7, 8. All right. So now when we observe these particular things, these corner atoms, all right. So the corner atoms that are W. Okay, now if you count it, those are 8, and everyone is going to contribute 1/8 of it. Okay, so the complete answer is 1. So here I'll have W as 1. Okay, so now let's observe the second scenario wherein they are speaking about the O atoms at the center of edges. Now these things are called as edges. So here we are going to have these atoms placed 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Right? So therefore, what happens in this scenario is that these particular atoms, now let's say that the edges, along the edges, right? So the atoms at edges. Now there are 12 edges. The particle at the edge is shared by 4 of them, 4 neighboring units. So therefore, in such conditions, it will become as 12 into 1/4, that is 3, and that is O is 3. Okay, now final one as what we have is about the sodium, Na atom at the center of the cube. So if it is at the center of the cube, that is going to be here, right? So now this particular atom, which is at the center, it contributes completely. So therefore, it's 1. That is, Na is 1. So as I have used Na before, first one, Na is 1, then comes is W, okay, and then comes is the oxygen, therefore NaWO3, and thus our option is B in this scenario. The formula is NaWO3.